the internals. Once the box has been damped out reasonably, it's not the effects tend to get swamped, so it's not that much of a big deal. So yeah, they're useful. There's no harm in them. If you can use them, great. If you don't, well, it's not the end of the world. Just try and avoid cubes, because you have massive problems with standing waves, which is also an issue that spheres have. One big, powerful standing wave, which the fans of spherical enclosures tend to gloss over a little bit, never let the truth and all that.
Just in the concrete sculpture course, I'm looking for an excuse to build anything in concrete at the moment. Good plan, anything I need to look out for?
Watch out for ringing, you'll probably need some bitumen damping on it. Concrete is not as acoustically inert as people tend to think it is. Some people have actually incorporated shredded rubber into it. Whether that's actually got a great deal of benefit, I suppose, will depend on the nature of the rubber and how much. I haven't tried it myself, but yes, you can use concrete. It's worth doing. Just make sure you got a forklift truck handy.
It was very popular at one point, wasn't it?
Yeah.
And there was actually manufacturers in the sort of late 70s, early 80s.
There's a lad somewhere in North Yorkshire that I think he's doing concrete acoustics or something. I did see a pair of his speakers a couple of years ago. I wasn't that impressed, it has to be said, but that was nothing to do with the concrete. It was just crap drive unit choice and lousy crossover and terrible port. And didn't bother finishing the concrete properly. But in principle, yeah, why not? Corian, we were talking about earlier, or marble. Marble I'd probably avoid. It's marble can ring something chronic if you're not careful. Slate, if you can find something that somebody who can actually cut it safely, because it's horrific stuff dust-wise, is slate. Again, it needs sealing and properly done. But yeah, these things can be done, and why not? They're not bad. Just don't assume that high mass is necessarily a good thing, particularly for base enclosures. A lot of the time, ironically, it isn't. It does ring, because it's got a fairly broad range of resonance. It's got a resonant frequency, and then it's a sort of low Q type. It can be problematic. So I would say, why not? But just go into it with the knowledge that it might not be as inert as you think it is. And the old knuckle test isn't actually that much of a guide, to be honest, because that's not really what you're doing there is not activating resonant modes in the same way that a drive unit will. A drive unit is not analogous to bashing on it, particularly with your knuckles, so you've got to be a bit careful with that. It can tell you a certain amount, obviously, of where maybe you need to put an extra bit of bracing or whatnot, but don't put too much stock by it. Accelerometers, like Stefan uses, is the preferred option, but it's not mandatory, especially if you're building them yourself. Wide baffles aren't fashionable at present, which is a bit of a shame, because they can often actually be quite good if you've got the floor space, or I should say the wall space, because if you get them near, they allow you to get your speakers nearer the walls, which is not necessarily such a bad thing. The further out the way for a start, and you can pick up more room gain, which can be quite useful on occasion. It means you can tune them lower for a start. So again, they also reduce baffle step losses, which I'll mention in a second. They have a reputation of having poor imaging. It's complete nonsense, isn't it? It's total drivel. They will image as well or as badly as you design them to. But yeah, they have certain advantages. So don't rule them out just because they're not necessarily fashionable. Narrow baffles, hyper narrow baffles were quite fashionable, what, about 10, 15 years back? Two examples. That is the Naga made by Clark Blumenstein over in America. A nice chap, actually. He's heavily into his skateboarding, actually, cross-country skateboarding, like a lot of people in Seattle are. That is 3.5 inches wide. There's a little Fostex driver that he's put in it. It's massive, it's 14-foot long horn is packed into that. The response is all over the shop, but they actually sounded quite good. I tried a sort of DIY version myself a few years back, and it's not particularly to my taste, but that's your narrow baffle taken to hyper extreme. And that is a speaker from, or maybe loudspeakers. They get their drivers actually. They get an American company to make them theirs. That's a little 4.5 inch. It's not a big thing. It's about 29 inches tall. About 12 inches wide. It sort of sits on its little plinth. You don't have to have the plinth. Longer spike at the front, 2 short ones at the back, angled backwards slightly, so it's firing at your ears. A little bit like these things do, actually. Except that the baffle angle is built into the design. And they image like gangbusters. They're great.
Next time you all come, I'll bring my speakers. My speakers are 40 odd centimetres wide. They're brilliant imaging. Obviously, you're right about the lowering of the baffle step. Mine are all vacuum formed, so they've got very large, sort of 4.5 inch round over. So
ideal.
Much better.
Yeah, ideal. But don't be afraid of wide baffles, just because people drivel about them on forums.
The other nice thing about the wide baffle is that you can often size the baffle, if you're doing multi-wide drive, but you can size the baffle so that the baffle step will correspond with your crossover frequency, so that you can...
exactly.
Sort of
if you want to push baffle step down into room gain territory, it needs to be about 30 inches wide. But that would be great. I actually designed, I think it was about 8 years ago. Remember the old cheap Pioneer drivers, about B40s or something like that, B20s I think they call them. Big 8-inch cheap wideband drive. They weren't really full range. They make about 12 kilohertz with the window at the back on a good day. But they sounded quite nice, and they cost about $15. And they cost nothing. I actually designed a big quarter wave for them. I deliberately shaped it by the 1x4x9 dimensions of the monolith from 2001. These bloody things were huge. A couple of people built them. They're massive things. They're about 7 foot tall, and about 4.5 foot wide. They were big, serious boxes. And the chap who built them pounded them with a couple of little piezo tweeters, and I thoroughly enjoyed them. And that pushed they didn't need any correction circuitry or anything like that, because they were so wide that the losses that you get, which I'll talk about now really, were shoved down into the territory where room gain compensated for it. Baffle step loss and edge diffraction are not the same thing, but they are related. I'll skip over this fairly quickly because we might actually start listening to something other than me. Basically, it's baffle step loss is if you got a speaker on a flat baffle, it's emitting a wavefront, and it's a spherical wavefront. Ultimately, sound is round. Well, it's not round, it's spherical, but you know what I mean. When the wavelengths get to the point where they're actually wider than the baffle, they start wrapping around it, the speaker is now no longer projecting those longer wavelengths directly at you. They're not being supported by the baffle. What happens is those lower frequencies at the listening position start to decrease below that frequency. Now, baffle step loss is one of those interesting little facets, because people get awfully precious about baffle step loss. So, right, we'll slap on immediately 6 decibels compensation, which, if you do it passively, means that you're cutting. If you've got a speaker that's got an output of 90 decibels nominal, and you put a full 6 dB correction for this on, you suddenly got 84 dB speaker. Hang on a minute. We're in a room. The speakers aren't floating in mid-air here, 300 feet above a field. Get with the program. It doesn't work that way. The energy is still in the room. It's almost impossible to get a full 6 decibels loss. It just ain't going to happen. At the most, most people will experience about 4 decibels, and that's under really nasty conditions. I think you have enough measurement.
It's also fair to say in the
yeah.
UK that we've got such small rooms, they're going to be in the corners of your
Exactly.
room, and unless you've got big corner-based traps like this.
Haywood, Peter Collier's little outfit. Most of his speakers, off the top of my head, he didn't really put much compensation into them at all, because they were designed, like a lot of early missions and various other speakers as well, again I'm speaking under correction, it's going by memory, were designed to be pushed near the walls. You don't really have much in the way of loss. So despite the fact that you'll often see this howling on the forums, like, you need baffle step compensation on these, you need a big inductor and a resistor on it, and you need to cut it. Do you? Not all the time you don't, especially with some of Mark's drivers, because he happens to have at lower frequencies, he's engineered a bit of a lift in the response into it, which naturally compensates for it anyway, which goes back to those, remember those mathematical TS alignments? Drivers don't always follow them perfectly. So these are this is why I said holistic design. You need to think about, don't follow overly prescriptive approaches when designing a box, because it won't necessarily end up working out that well. So that's step loss. It's essentially a reduction in sound pressure levels, output volume basically, at the listening position, caused by the low frequencies, caused by the fact that the baffle isn't supporting those frequencies and allowing it to fire directly at you. Technically it's moving from 2 pi radiation space to 4 pi radiation space. Basically it just means that it's radiating more sort of omnidirectionally below that frequency. If you want to be specific, you can take it as 4,560 divided by the width of the baffle in inches. That'll give you a sort of rough baffle step frequency. But I wouldn't get too picky about it, and don't assume that you need 6 decibels worth of compensation. If it's a multi-way, you can build a lot of this into the crossover. If it's a widebander, you can put on, you can parallel up a resistor and an inductor, and then put them in series with the driver, and it'll bring the response at high frequencies above that down into line. But chances are you'll probably only be exhibiting, in most UK rooms, about 2 decibels loss, and a lot of that is going to get compensated for room gain quite quickly. In my experience, particularly with Mark's drivers, don't bother. It's not worth it. Edge diffraction, in fact I'm going to skip over that, other than noting that too much is like baffle step, too much it can often be made of it. It's like, oh, you must have, must we? You have to have, you know, you get all this on forums, and you just, oh God, let's get on with it. The truth be told, most of the chamfers that you can put on boxes, which are supposed to help with edge diffraction, or even a lot of the curves for that matter, unless they're a big radii like the sort of 4-inch you're talking about, they won't make any difference. They don't. That's the truth of it. Basically what happens is you get an acoustic impedance mismatch at the edges. You get a shock wave, in fact, basically, and the edges end up starting to act almost like other emitters, but they're delayed in time. So you get nasty sort of peaks and dips in the response caused by it. I won't bore you with all of the details on it.
There's some great resources out there.
There's loads on the web.
Edge illumination or
whatever. So I mean, play about with some of the free software. I can recommend some various software. Stefan can, as Mark no doubt can as well. That you can sort of play about with this. But what I do say, try and sort of take a broad overlook of various factors involved in loudspeaker design, but don't get overly obsessed on any one specific, because chances are, if you do, you'll sacrifice something that's actually more important. It's a bit like, you know, I said, sacrificing a perfectly flat mathematical response for a sort of more damped response, and a practical flat response when you put it under normal room conditions, yeah? The price of that is slightly higher group delay. I know what I'd rather choose.
You know, in sort of commercial terms, we all, you know, if you ask guys like us, when we say, well, flat response, we say, well, yeah, it's a flat response. Is music flat? No.
Mm.
You know, that's the last thing it is.
Yeah, this is the truth of it. It's, in practice, you know, the world doesn't work that way, as Mark says. You know,
If you
there
want
are,
a flat response, just put a handkerchief over your driver, that'll do it.
Yeah.
Flat response, but that's what you'll get.
mm,
You know, so
It's-
would you then think of that as good sound? Most people probably will say no.
not a chance. Again, you know, it's a case of holistic. Try and consider a wide range of factors, but don't become overly obsessed on any of them. As far as boxes go, a lightly damped response is usually more practical with base reflex designs. Other factors, other types of enclosure, you know, we don't have time to discuss today. Damping and ducts, skimming this very, very quickly. So fancy materials, generally speaking, you know, the angel hair wool pulled from the virgins of the southeast. Oh, spare me, no, forget it. All materials are slightly different in the damping characteristics. There is not necessarily one that is the holy grail of it. You can, most things like hollow fibre pillow stuffing generally is perfectly good. It's not all created equal. Some of it depends who made it. Some of it will have slightly different characteristics compared to some others. So, you know...
So the stuffing that I use and that I put in these speakers just, you know, is a hollow fibre dichrome type stuff, but it's carded. So the idea is you get an equal spacing of kind of, you know, hair and
Excellent.
air, as you know, across the whole volume.
Yeah.
Whereas, you know, some of those other ones, and especially the wool, you know, the long-haired one, obviously you tend to get clumps,
lumpy,
and you know that's not also the end of the book. 'Cause obviously, you know, it offers different kind of impedance, and you know
moths as well. If you desperately want to use wool, just for the sake of it, make sure it's treated. These moths are not a joke. It can have massive problems with them. I wish I was joking with that, but I've seen what happens to people who have used untreated natural wool. The moths have got in, and they have got everywhere, and I don't just mean in your speakers. It's not a joke. So yeah. As a few general other remarks, I would suggest for the most practical vents, try and avoid it if it gets more than 6 inches long. If it gets to sort of extreme lengths, then I suggest you need a smaller vent. Vent length increases as its diameter increases, so a wider diameter vent needs to be longer for the same box volume and tuning frequency. If it gets more than about 6 inches long, you're risking getting... The vent is just a tube, ultimately, that's open at both ends, otherwise known as a half-wave resonator. It has its own harmonic structure, and you will start hearing some of this stuff. That's why, anybody seen Onken type boxes? Look, they've got an array of big vents up the sides, yeah. Now, I suspect a lot of people, a lot of their fans, like the fact that you can actually hear this harmonic structure rippling through them, because they've got very, very long vents. They often require just a little bit of damping inserted into them just to kill some of that. Onkens can be great, but, you know, very long vents are best avoided, as a general rule, with sort of standard base reflex boxes. Also avoid very high... If you use slot vents, because you can use rectangular vents, and they work basically the same way, it's just area and length, that's all it is. But if you get very high aspect ratio vents, slot vents, where your sort of width is massively stretched relative to the height of it, watch it, you'll get frictional losses with it. As a sort of rule of thumb, personal rule of thumb I use is, if it's more than 1 to 9, you need to change the vent dimensions a bit. Otherwise, you'll get a lot of frictional losses from that, which might be advantageous in certain cases, but it will also put the velocity in the vent slightly higher, ironically enough, which can result in, again, audible vent noise. Floor standing enclosures. Big floor standers, again skimming through it. If the length, otherwise known as the height, of the box is massively stretched compared to, say, the width and depth of it, if it's a massive increase compared to those, you probably have some kind of standing waves building up in it. Be cunning. The box will probably need some bracing. Use the brace to break those up, or braces to break those up. That's a good way of doing it. Yeah. Unless you've designed it to have those and have accounted for those in the box in the first place. Wish I could talk about that today, but I can't. It would take far too long.